I'm Andrew Ray. I'm an assistant professor at Kentucky State University in the aquaculture program, and what we've done here is we've grown some shrimp in a biofloc aquaculture system. And so the biofloc approach is a recirculating aquaculture approach where we contain the water. We only exchange up to or around about 5% of the water throughout the entire life cycle of the animal. And so what that allows us to do is save water, and we can do things like grow marine animals in a place like Kentucky. We often situate these systems indoors, although people do operate biofloc systems outdoors, mostly in lined ponds. Indoors, we can heat the tanks and we can grow shrimp all year round. Tilapia are also commonly grown in biofloc systems. There's been a lot of work with catfish, and there's a lot of potential for other animals too, especially animals that can eat some of the natural productivity in the water. So biofloc refers to particles that exist in the water column. We put animals in, we feed the animals a complete diet, and part of the food and the waste that's created from that turns into bacterial biomass, and this bacteria flocculates together in small particles that are visible with the naked eye. Some of them actually are a little smaller than what you can see with your naked eye, but these particles consist of bacteria, zooplankton. If the system's exposed to light, there's going to be algae in there, detritus, uneaten feed particles, and the like. And so these little particles that are in the water are what's given this water, this biofloc water, its color or its turbidity. And shrimp and tilapia are really good at eating these particles out of the water. They can actually filter or otherwise obtain these particles and eat them. And so what that does is recycles the nutrients that are put into the water. So we put the feed in, part of that turns into biofloc, and then the animals get a second chance to eat those nutrients. And so what we see in biofloc systems is we see much lower feed conversion rates. That is that the amount of feed that we put in, if we put in, we have to put in about 1.3 pounds of food, and we get 1 pound of shrimp out. And so from an agriculture perspective, that's extremely efficient. And so with those types of feed efficiencies, the cost of feed is reduced, and feed is actually typically the most expensive recurring cost in an aquaculture production system. That's the real primary benefit of operating a biofloc system. The other types of systems we operate in this building, in our production technology building, are clear water recirculating aquaculture systems, where we use filters to take everything out of the water. And so for shrimp and tilapia and other animals, the biofloc systems are a little better for them probably. The systems, we're able to stock them at a very high density of animals as well. So we can get, in a small tank inside, we can get similar production to what you might be able to get in a much larger pond outdoors. Also, because the systems are indoors and they're heated, we can control temperature, and we can produce shrimp or tilapia or other animals all year round. There's other animals that people are considering for biofloc systems, such as larval fish that have a high rate of cannibalism. There's some anecdotal evidence that suggests that because of the turbidity of these systems, cannibalism might be reduced. So there's a lot of potential for biofloc systems. One of the drawbacks to a biofloc system is that it's biologically rather complex. You have to understand, you have to have some base knowledge of what these bacteria are doing in the water column and how they interact with the animals that you're growing. And so you need to understand water quality. Also, the bacteria being in the water column consume a large amount of oxygen. We found that sometimes the bacteria can consume as much oxygen as the cultured animal itself. So we need aeration. Also, you have to control the concentration of biofloc. We do use filters. Typically we use a foam fractionator in our saltwater systems, or we use a settling chamber, which is very simple. To grow saltwater species in a place like Kentucky, we simply use filtered tap water, and we add sea salt. This is a sea salt product that's actually made in Baltimore, Maryland, and we just simply add this sea salt to filtered water and bring it to whatever salinity we'd like to operate our system at. For our marine shrimp that we just harvested today, we grew them at 20 parts per thousand salinity, where full strength seawater on average is 35 parts per thousand salinity, so considerably less. We have another tank where we're growing shrimp at 10 parts per thousand salinity, so less than a third of the salinity of ocean water. So that's one of the things we're working on, is growing the animals at a lower salinity so that we don't have to buy as much salt, because the salt is reasonably expensive, but again, we reuse the water over and over again. Right now, people are pumping the water that we drain for our harvest, they're pumping it right back into the tank, and we're going to restock it with animals tomorrow. But what we found so far in our biofloc system indoors here in the production technology building at Kentucky State is that the water quality and the shrimp growth was very consistent throughout the entire culture cycle. We got right about just under 2 grams per week of shrimp growth, which is very good. We're very pleased with that, and typically for marine shrimp, Little Penaeus vaname, our Pacific white shrimp, we get them from a hatchery in Florida, and at that point the shrimp are about 30 to 40 days old, but still they're very, very small. And we call those post-larvae. They're just past their larval stages. And so when we get the shrimp, they're usually about post-larvae 8s or 10s, and that means they're about 8 or 10 days past that larval stage. We put them into a nursery tank, and we can stock shrimp in our nursery tank at about 3,000 animals per cubic meter, maybe a little bit less if we're going to play it a little more safe. And we put them through the nursery phase for about 30 days. And at that point, they're about 1 gram in weight. And then we put them into our larger production tank that you saw, that we harvested today. And we stocked those shrimp into that tank at 250 shrimp per cubic meter. Our next batch we're going to stock at 350 per cubic meter, and if that's successful, I plan to go even higher than that. And so the idea is that we stock more shrimp, we get more biomass at the end, and if this is a farmer that's doing it, obviously they're going to make more money. So that's the way we stagger the production. By doing the nursery in a smaller tank at a higher density, we can conserve space. And so right now, our nursery shrimp are ready to go into the grow-out tank. We stock the nursery tank about 30 days prior to the harvest of the grow-out tank. That way, when we get the shrimp out of the grow-out, they're ready. There's a new batch ready to go right in. So our big production tank that takes up the most space is never, or virtually never, maybe just for a few minutes, it's empty. And that's how we can utilize space very efficiently, because when you're in an indoor building, you only have a certain amount of space, and you want to use it as efficiently as possible. The shrimp that we harvested today are about 26 grams in weight. So they grew from about 1 gram up to about a 26 gram shrimp. And our grow out cycle took just over 90 days. I think we're right at 95 days, if I'm not mistaken, to grow from about 1 gram to about 26 grams in size, average individual size for the shrimp. And that's a little bit under 20 shrimp per pound count, head-on, fresh, whole shrimp. And now these shrimp are going to go to people's dinner plates, and they're going to enjoy them. Okay, here we have about 5 pounds of fresh, whole, head-on, never frozen, white shrimp that were produced indoors in our recirculating aquaculture system. And some of these shrimp we're going to take to various seafood distribution centers and chefs. We've got a chef who owns 2 restaurants in Lexington. We've got a restaurant owner in Lexington that owns 2 restaurants, and a food co-op that are going to take about 15 pounds of these, and they're going to give them to their clientele. They're going to prepare them in various ways. They're going to give us some feedback on the product, and we hope to learn what people like about the shrimp, maybe if there's things they don't like about the shrimp, especially things we could change through aquaculture or through post-harvest processes. And we hope to find out approximately what people might be willing to pay for these shrimp, so we can provide that information to potential farmers. All right, so if you have any more questions about indoor aquaculture systems, marine shrimp, biofloc, or anything else related to aquaculture, please feel free to contact me. Again, my name is Andrew Ray. I'm an assistant professor here in the aquaculture division at Kentucky State University, and my email address is andrew.ray@kysu.edu. That's ANDREW.RAY@kysu.edu.